and welcome to the Space Policy edition of Planetary Radio. I'm Casey Dreyer, the Chief of Space Policy here at the Planetary Society. Welcome to the show where we look into the processes and politics and policies behind the decisions we make in space exploration. This month, I really had fun looking into a historical example that I think is somewhat relevant to our situation now, and I drilled down into a particular event. A little bit of context is necessary before we get into that. The announcement of the Allan Hills meteorite discovery in 1996, where a paper and its authors argued that they had found evidence for past Martian life. Some of you may remember this. It was a big deal at the time and got a ton of news coverage for what it claimed to do. Obviously, we have not seen follow-ups on that in the sense that the claims were proven incorrect, but the outcome is often associated with a massive increase in attention towards Mars exploration and robotic exploration. Some arguing that it actually led to the explosion, the golden era of Mars exploration that we had for the last 25 years, seeing a mission nearly every Mars launch opportunity, multiple rovers, multiple orbiters, a fleet of spacecraft now at Mars, thanks to that humble rock. Allan Hills was on my mind a lot this last month because of a new paper that came out in the journal Nature. This paper basically said that there is likely a potential biosignature in the sample cache of the Perseverance rover currently operating on Mars, the first step of the planned Mars sample return campaign to collect scientifically valuable samples of the surface of Mars to understand and characterize the geology and area around it, and then bring it back and study it in the most advanced and capable Earth laboratories that we have to do the types of scientific experiments that you just can't do on a rover 100 million miles away from Earth. This goal has been a goal of the scientific community for arguably 50 years since the Viking landers. It is also now one of the missions identified for cancellation by the current administration. But Mars sample return, its problems predate this administration. It was functionally put on ice, nearly canceled, but stopped functionally in its tracks over 2 years ago under the Biden administration that spent the following multiple years in the face of growing costs and uncertainty in terms of management. Mars sample return was estimated to cost at least $11 billion, functionally pausing the project and causing huge layoffs at JPL and elsewhere around the country. But the problem now, or the plan now, is not to fix that. The plan seems to be to not do it. Or in the best of case, maybe human astronauts will pick up those samples later. That is a, let's say to me, underwhelming response to what could be a historic discovery, or at least a profoundly important one if there is a null result. The idea that Allan Hills in the 1990s, despite the fact that its claim was ultimately dismissed, led to a golden era of Mars science, and contrast that to a provocative claim, and I should be clear, nowhere near at the level of confidence presented in the 1990s paper, but one nonetheless of a potential biosignature, maybe leading to nothing, or maybe at best leading to something decades down the road. Why are those two different, even though if you look at it, the conditions are very similar? That is the groundwork that I'm laying here before we enter into my conversation with Lou Friedman, the Executive Director Emeritus of the Planetary Society, one of the organization's co-founders, and someone who has advocated for Mars sample return through his entire career, starting in the 1970s, working on one of the early studies for Mars sample return for NASA, and then, of course, carrying through as one of the founders and leaders of the Planetary Society to now in his role as Executive Emeritus. He is a person who does not mince words and clearly argues for Mars sample return in a way that I rarely hear. And we look at together the distinctive era that he lived through in the late 1990s after the claim of Allan Hills, We compare it to this new discovery that was made through NASA's Perseverance mission. And we also look at the changing responses. Why did one seem to ignite something where this one seems very different? And I will also add there is a fascinating and telling way that the scientific community, or at least some among the scientific community, seem to engage with the Allan Hills experience that directly impacted the outcome of the current paper that came out earlier this year. It is a fascinating to me, and I think the start of a deeper understanding and conversation about how things happen in space science, what ignites them, what generates the attention and the policy effort and the motivation and energy to be put forward for these things, and why and when. This was a fun conversation. It's slightly long, so before we go into it, I need to say, if you are listening to this and you are not a member of the Planetary Society, please consider joining us at planetary.org/join. Your membership is critical. We are not an organization that takes government money. We don't have big aerospace industry investors. We depend on individuals to operate. So if you like this show, you like our policy work or other things that we do at the Planetary Society, please consider joining us. Just a few bucks a month to start. Planetary.org/join. There's also ways to donate at planetary.org/donate for specific projects. So consider that. And if you are a member, thank you very much for listening to this and for your support. We literally could not do this. That's true. Literally could not do this without you. As a note, the papers referenced in this discussion and related items that we talk about will be linked to in the show notes. And here we go. My conversation with Lou Friedman. Lou Friedman, delighted to have you with me on the Space Policy edition of Planetary Radio.
Glad to be here, and it's nice to talk to you and nice to talk to members of the Planetary Society.
Lou, one of the reasons I wanted to have you on is you have been a very vocal supporter of Mars sample return over the last few years, Mars exploration more broadly, and in a way that I think most, particularly for Mars sample return, we haven't really seen too strongly among the community. Why do you think Mars sample return is having such a hard time right now?
Well, thank you for the question. It's one of my favorite topics, except it has a very unfavorable outcome. I've actually been with Mars sample return ever since my days at JPL when I actually led the Mars sample return study. I think the first one that got presented to the National Academy back in the late 1970s. So I've been part of on both sides of the coin here of trying to sell it to the management and to the decision makers, and then also watching other people try to do that and seeing it in the eyes of the public. And not only has the public not resonated with Mars sample return, but the science community hasn't supported it very well, and NASA has supported it not at all. And I think that is part of why it's having so much difficulty. It doesn't even have support from the government agency that's asking for the money of it. And that's a political point, and I'll come back to that. But the main thing about Mars sample return was always bringing up the huge cost it has. It is too big for the science budget. And I said years ago, it is not just a science mission. It should not be in the science budget. It's an exploration mission at the level that NASA should be a fundamental purpose of exploring mysteries of the universe and all the questions that go into planetary exploration. But NASA has never recognized it as such. They want to stovepipe it into the science budget and make it compared with other smaller science missions, and then the science community splits apart into different constituencies, and they break it up, and it loses both its broad base of support as well as the incisive reason. The other thing is that as an exploration mission, the human exploration side, which is called the Exploration Division, they don't even recognize Mars sample return. If you go to NASA and ask them, can I have a copy of the Moon-Mars architecture? They'll give it to you, and they won't even mention Mars sample return. If you ask them about it, they'll say, oh, that's a science thing. So again, it's stovepiped into these little boxes, none of which is big enough to support the large cost of the mission. And the large cost of the mission is not just because of the spacecraft or because of the instruments, but it's all the things you have to do with it. You have to take off from another planet. You have to have rockets on both ends of the mission. You have to have rendezvous in different parts of the solar system. You have to transfer the samples through several procedures, each with rigid controls on planetary protection. And then you have to recover the sample. And then you have a huge cost in the Earth-based facility to do it. So it's a large cost, but you can't blame it on, they just made the spacecraft too expensive. And that brings me to the other large cost mission, the James Webb. James Webb Space Telescope was $11 billion. Correct me if I'm wrong. It was about that.
And yeah, adjusted for inflation, yeah.
And it got support. And when it needed more money, it got more support. And when it was delayed a year or two, it got more support. Now, why? How come that resonated with the public? Well, the main reason is because it was exploring the mysteries of the universe, the origin of the universe, they said. We're going to go back to the beginning of time and see the birth of the universe. All overstated claims, but not stupid statements. They're simplified statements, and people resonate with that. That's what they want NASA to do. It's the mysteries of the universe. Well, I maintain Mars sample return is even more important. It's going out to study the origin of life, and NASA would never admit that. In fact, if you brought that up at a meeting, they'd say, no, we don't want to bring that up. It's too controversial. Or no, it's not rigorously proved. But the whole fundamental questions about that we don't know, the whole evolution of how chemistry led to biology is unknown here on Earth. We know that we had the right chemical molecules practically at the time Earth was formed, but we don't know how they became biological. But it happened very quickly. Does it happen like that elsewhere? Well, we have no data on that yet. And that's the key thing about science. You need comparative data. So the mystery of the whole origin of life is really related to the chemical analysis of what you can do on Mars samples. And we now have a situation where we might even have that sample, but NASA won't admit it. And so there was never a willingness on the part of NASA, and I must say, on the part of the science community, to simply say, yes, we need this because we want to understand the origin of life. That's worth $11 billion. There wouldn't have been any argument about make it smaller. They would have said make it bigger, if they had admitted what it was really for.
Well, I think that's would they have? So I think there's three threads I want to follow, but let's start with the science community response to the threats to Mars sample return, because I was honestly surprised by that to a certain degree. There was always, I was aware of a certain strain of reluctance, let's say at best, an outright frustration with that, in that it was going to be too big, it was going to go over budget inevitably, it was going to eat up the budgets for every other science. I think that was the fear of a lot of planetary scientists who weren't into Mars sample return. But nonetheless, it was the priority of this decadal survey, right? So it does have this imprimatur of, official scientific approval through that lens. But what I think it has shown is that is the decadal survey properly reflecting the priorities of the science community based on the lack of scientific community support once it did run into trouble. And the other aspect of this, I think, is structural of what type of mission it is. And also, I think this is a big distinction of James Webb Space Telescope. JWST, you can point it anywhere, right? As long as it's in space. You're a planetary astronomer, you point at a planet, you want to look at origins of galaxy formation, you can do that. You can look at star formation, just point it wherever you want. You have so many different parts of astronomy covered by it. Mars sample return is it has really broad implications, but the scientific, I think, questions are very narrow in terms of what parts of the community they intersect with, right? And so you don't have a lot of community engagement with the process of the scientific results. You have a lot of refinements of broad community hypotheses based on the results done by the geochemists. And then also, but not for 20 years, right? All the science is backloaded. So I wonder if there was just like a fundamental structural framing of how Mars sample return was proposed to work that just made it, in a way, not motivating the very community itself, because it didn't actually intersect that community in the same way from a working scientist perspective.
I think your analysis is good and you correctly. I think you're perceptive in how you frame that and discussed it. But even with James Webb, it can look at anywhere. It can probe fundamental knowledge about origin of galaxies, about star birth, about the motions in the distant universe, about possible even other matter out there. But the real thing that ended up selling James Webb, and a change in the priorities from their original plan to their actual operation plan, was about exoplanets. Exoplanets changed everything for James Webb. Now, why are exoplanets so interesting? Well, for one thing, James Webb is uniquely able to see them, but they can't image them. Now, you can't do the kind of imaging of exoplanets with James Webb. But again, it comes back to that question. It was solving a mystery. And so I think even with James Webb, with all of the breadth that you cited, it ended up focusing on the key question. And NASA and the science community at NASA was unwilling to let Mars sample return. NASA's been unwilling. We all kind of grew up in the era where we were disappointed that Viking didn't find animals running around on Mars. And the public was so disappointed. And what happened? We had almost 20 years of no Mars exploration after that. It was a disappointment. Mars is boring. It doesn't have anything for us. And then everything changed again in the late 90s and early 2000s. And we realized it's an interesting world. It may not have animals running around on it, but we don't know if it doesn't have the same kinds of early conditions, and it's the only tangible thing. Think of all the talk we've done about extraterrestrial life, whether it's in books, in science fiction, in SETI, in remote observations, in people's pseudoscience about alien visits. This is a huge question of enormous public interest. And the only tangible extraterrestrial life experiment we can do is touching a piece of Mars. Because if we find something on Earth, we have to have something to compare it to. And we're never going to pick up a sample anywhere else but at Mars. Well, I say never, at least for a long time. And so the only tangible extraterrestrial life experiment you can do is grab a piece of Mars and look at it. But NASA and the science community is unwilling to frame it and look at it that way. They're afraid of bringing up the extraterrestrial life issue. They're afraid that, we don't know exactly if that's true or not. We have to verify it for 50 years or 100 years. That's certainly true if you're a scientist, but in terms of public interest, these are the questions we want to explore. It's not about science. It's about exploration. If we knew the answer, we wouldn't be exploring.
Right.
So the public will very well accept uncertainty. The proof of that is the previous discovery. Mars life has been discovered several times, by the way. Mars life was discovered back in late 1930s, when it was broadcast on Earth that the Martians had arrived in New Jersey. And people got all excited. And then Mars life was discovered by Percival Lowell, who saw the canals and the things that they dug.
I have a clipping from the New Yorker in 1956 talking about a perihelion or a close approach with Mars, where scientists were observing changing colors on the surface. And it was thought, it's probably lichen or some kind of algae.
Right.
We'll see. And it was just so matter-of-factly, and it was that was that. It's like, wait, there's life on Mars?
Right.
There's living things on Mars? That seems more than, one tiny little paragraph to mention.
Yeah.
But you're right. There was just kind of this perception of that, right?
And then, of course, we had the great discovery in the 1990s with the Allan Hills meteorite and the possibility of Mars life having been embedded in a fragment which was blown off of Mars, wandered around the solar system, made its way to Earth, was picked up on Earth, analyzed, found to be the same constituents as the Martian atmosphere. It came traced back to the fact that it came from Mars, and it looked like it had evidence of microorganisms that might have been on Mars. And that was then later discovered to be uncertain and probably even not correct. But the public wasn't angry about that. The public was enthralled by it. They supported the idea. What was the reaction to Allan Hills 84001? It was, hey, we got to get up there and explore more. Mm-hmm. And so after 20 years of not exploring Mars, after the Allan Hills meteorite, we had 20 years of rapidly exploring Mars.
Right. We will spend a lot more time on Allan Hills, but I want to just go back to a few more things in Mars sample return, because I think that's such an important, that's our current challenge in a sense. You, I think in the last 10 minutes, described Mars sample return with more verve and excitement and clarity than I have heard anyone pretty much in the last 5 years talk about it. And I think that may be part of the problem too, because you highlight the life question, which is what I'm personally most interested in. And again, we'll keep going back to this. I think the scientific community is really hesitant to make that a priority of the mission, at least officially. And so you end up having, again, all these other valuable things that it does, but it starts to become, what's the clarity of the message? And I think there isn't one with Mars sample return as it's been presented. It's just, we need to get these rocks back and we'll learn a bunch of stuff, which is true, but less compelling in terms of framing. The other aspect, I think, is just the name. I think about this a lot, sample, right? Most people, when they hear, the word sample just doesn't evoke excitement generally. I think most people will hear it either like at Costco or when they're going to the doctor, right? And Mars sample return doesn't really get to the core, right, of what it's doing. I couldn't agree
with you more, Casey.
But that name has been around for 50 years. They haven't come up with a better one.
It's all my fault. No,
was that you?
No, not really. It's we haven't come up with a better name. Now, of course, what was the James Webb telescope originally named? I think it was the Very Large, it was
infrared. Yeah, I forget exactly.
It was a large telescope name, and it was it was called the Large Space Telescope or something.
Yeah, and
maybe that is equally boring. Maybe we could have called Mars the Small Space Microscope. Maybe that would be better. But then it got the name James Webb. Now, James Webb is not a household name, but maybe if we had named it the Carl Sagan Mars mission, it might have caught on better. I don't know.
I would have liked that. But I think there is, though, the clarity of, I think, to the public of what this does, and then beyond just being expensive, may have been part of the problem.
Part of the problem, you alluded to it, about rocks. I've sat in so many meetings where they put down the idea, oh, geez, another geologist, all they do is they collect rocks, they're rock hounds. But I remember sitting at a meeting where we were trying to bring the Mars sample return to a high-level science advisory group. And one of the scientists, who was the head of the committee, said, you give me a piece of Mars, just any piece from any place, and I'll tell you the whole history of Mars since the beginning of the solar system. And then there was this huge 2-hour debate on that statement. But it was an overstatement. It's not true, most people would say. But even that didn't capture what we really want to know from the Mars sample. So if you tell somebody you want to learn the origin and evolution of the planet, they'll say, oh, that's pretty interesting. But I don't think it's as exciting as I want to learn the origin of life. And it's not just the origin of extraterrestrial life. It's the origin of us, life on Earth. Because again, that whole relationship between the chemistry and biology can't be answered except by picking up samples from different environments and worlds and looking at the different things that you've had a number of astrobiologists on this Planetary Radio who've talked to you about this, the comparative astrobiology that we need to do, especially at the molecular level. And my perception of it came from a book by Mario Luvio and Jeff Shostak called Is Earth Exceptional?, in which these two people, geochemists and an astrophysicist, nothing to do with planetary, neither one of them planetary scientists, said the only way we're going to learn about extraterrestrial life is with this chemical analysis on the Mars samples. That was an eye-opener for me.
Well, I've always seen that as an issue with you're choosing for like planet going in this direct kind of not even in situ, but bringing back these samples, doing the chemical analysis, molecular analysis, looking to understand life. It's a lot targeted on a very small, you can only do that a few times, right? Because it is expensive no matter how you do it. But then you have this alternative approach through, your photon collecting, right? Through astronomy, of doing the large telescope. Then you can do larger surveys. You can look for hundreds of exoplanets, maybe Earth, like the upcoming Habitable Worlds Observatory, trying to find these, but you don't ever get the chance to do that kind of
analysis. We're going to spend that kind of money on looking, no matter what we use on exoplanets, it'll never be more than a pixel in any image from Earth.
Right.
So we'll never see an exoplanet, period. We're not going to go there, and we're not going to see it up close. So this idea that we're going to do these spectral measurements of atmospheres and learn all about extraterrestrial life is a way overselling. When we discover water on Mars, nobody's willing to say that's life. What is it going to be when we discover a particular molecule in a particular exoplanet atmosphere? Oh, that could be from life, or it could not. That's what will always be the answer. The only tangible experiment we can do on life is with the Mars sample. If
there is something there to be measured, right? So, and I think you can almost see like it's the two ends of this argument. So if you do the astronomy approach, you'll never have, I think you're right, you'll never have anything more than a debated biosignature, right? Because there'll always be, you'll never be able to, unless it's waving at you or talking to you, you will never be able to do, I imagine, the kind of constraints necessary to definitively apply this is biosignature versus potential versus there's some weird abiotic process that can theoretically create that. I think the flip side of that is that because you're doing a broader statistical survey, it would tell you if you have one or more candidate biosignatures, even though you'll never know what they are necessarily or what their chemistry is, it would maybe give you some confidence that we are finding something out there. Whereas Mars, we don't know if there was life to be found there, right?
It is true. All of our observations of the universe and planetary science, but even and exoplanets, they're very broad, multidisciplinary. Lots of things to look at. Whereas the way Mars sample return is sold, even you said it earlier, we think that all we're going to get out of it is one little speck to look at. And if it works out, it's life, that's wonderful. But if it doesn't, we've lost. That's not true. What we'll get from looking at Mars samples, and I emphasize it's plural, is you'll be looking at environments. You will be putting together an origin and evolution of another planet, a near planet, the only planet that we humans can reach if we ever do decide to get off of this one, and the only place where we can reach where we can actually capture life. So you're going to be learning just like saying, well, we go to one spot on Earth, we learn something about that one thing. No, you learn about much more. You learn about the Earth and its history and its environment, its evolution, and all of those things. Well, that'll be true on Mars. And again, that's part of the problem. We've sold it as one Mars sample return mission. It's really not. It's going to be many. it's like the ships going out from Europe to the Americas. It wasn't one mission to discover, is there gold there or is there not? Or are there people there or is there not? Or is there good vegetables there or is there not? It was many voyages over hundreds of years. And I'm glad to see the Chinese approach is for a simple Mars sample return first, and then increasingly more complex ones, so that over a 20-year time period of the 2030s and 40s, they'll be probably doing that increasing sophistication of Mars samples.
And just to be clear, because they're just going to land, grab whatever samples they can.
On the first one.
Yeah.
Whereas the American mentality was the first one is the only one.
Yeah. Okay. So that's a super simple, get something, bring it back versus, which I guess the something is better than nothing mentality, which seems like it's about to work.
Well, also it has the engineering advantage of, if it doesn't work or what we learn will be useful in later steps.
The next one.
Yeah.
That brings me to, I think, the other distinction between Mars sample return challenge right now and where James Webb was back in early 2000s. It strikes me that there's not and this big challenge even from the advocate side, there's no programmatic architecture that seems like it's going to work. That strikes me as that, and that's, I'd say, pretty much a lot of responsibility for that is the prior leadership of NASA slow walking these studies on Mars sample return for years and then producing no confident path forward at the end of it. So what is the right way to get there? NASA hasn't put one forward. I'm not an engineer. I can't say which is a lower cost or a higher quality or more reliable one. We have options now from Rocket Lab. They'll say they'll do one for $4 billion. Lockheed says they'll do it for $3.5 billion. JPL was thinking 7 or 8. But we don't, what's the evaluation process? I think that's one of the huge problems. Like, even if we get money towards Mars sample return, to whom is this money going and to what architecture is going to succeed in this?
Well, yeah.
Well, I mean, it's more that, there's no pathway for it, right? That's the problem.
All the smart people who understand this in a room, let's say there's 20 of them, there'll be 40 opinions or 50 opinions because the answer is there's no right way or there's many right ways. And it's a very complicated question because the argument that we're only going to get one shot in our lifetime, so let's do it right, which is what the current approach to Mars sample return has been, versus the approach of, this is a part of a program of exploring Mars that's going to go on for decades. That's something NASA has never wanted to do. And the OMB in our country has never wanted to do. The OMB lives in fear of making any future commitments. And so they've always hated Mars sample return because by its very definition, it's a future commitment, at least to the return of the sample and then to following it up in some way.
But at the same time, ended up being fully justified for them this time. I mean, that's what's so frustrating about this process, right? Is that they were getting $1 billion a year for there. And then suddenly their budget went from 6 to 11 billion before phase C even started. That's no wonder the OMB, I mean, that validated every concern that the Office of Management and Budget had about that, right? I mean, I think that's what's also frustrating is that the management almost self-collapsed the project.
I mean, I do think it was put forward badly in that regard. And by the way, this wasn't the first time. I told you that even in my era, in the 1970s, we proposed Mars sample return. In the early 2000s, there was a very good Mars sample return proposal from JPL in cooperation with the French and Europeans, and it could have been affordable maybe under certain circumstances. There's a lot of people who are part of that who feel that the approach taken now was too grandiose. That was pretty much the fault of the science community. They went and they said it was number one priority, and they then said in an extraordinary statement, which I remember when it came out, we criticized at the time, and if you're not going to pay for it this way, if you're not going to do it this way, don't do it at all. If there can't be Mars sample return, don't do it at all. And now what they're getting is nothing. So I think that I don't have a good answer to that question of why, except to come back to the very fundamental thing I said at the beginning. This is not a science mission. NASA should have never stuffed it in the science division. It should be an exploration mission. It should be put in together with any ambition that NASA has about the future of exploration, integrated with what we want to do in the human program, which, by the way, we haven't talked about at all, but it's even a bigger
that's my
mess.
next question.
It's a totally dysfunctional.
Yeah.
If you had considered all these things together, you could come up with a rational program. You could come up with a series of robotic missions that lead to human teleoperated missions on the surface of Mars with a greater human involvement, and not trying to waste a lot of money on human landing systems for the humans on the one hand, that are at least 3 decades away, on trying to do a Mars sample return by stuffing it in the science division. You had to consider the total thing together, and NASA is not structured to do that.
After the paper was published for the Cheyava Falls potential biosignature discovery, Jared Isaacman, who was no longer at the time a NASA administrator nominee, but now is again, at least as the time we're recording this, tweeted something to the effect that we need to get humans to Mars right now to get these samples back. What would you tell him or people who would say, oh, and actually this was actually in the skinny budget proposal that killed Mars sample return funding?
Yes, an extra $1 billion for...
Yeah, that it would be, humans will do this anyway, so why do we need to send robotics to do it?
Well, what I would say to him is, being the diplomat that I am and being never wanting to alienate somebody I talk to, I'd say, you're right. We do need to get humans to Mars. Now, here's what's involved in that. And go through the steps on that, you see it's at least several decades away. We don't do it without robotic precursors. We don't do it without the scientific knowledge of the surface environment. We don't do it without testing the launch of a vehicle from another surface. We don't do it by building the biggest entry system we can to support the weight of 4 humans before we build the biggest entry system we have to support the weight of a small rocket bringing back a Mars sample. In other words, I'd give him the program that would have led to the humans bringing back samples from Mars someday. And in my head, I wouldn't have told him this because he's a human and therefore he's in favor of humans. I would have said, by the time you get into that program, you will find that there are probably better ways to use the human than by sending them out to pick up the samples. You'll send out their machines to pick up the samples, and the humans will do the scientific and thinking work with those samples. But I would have gone along with the idea that the human to Mars is the driver, but I would have said how to get there would have been the robotic and Mars sample return steps that we need to get there. NASA was totally unwilling to do that. Like I told you, even today, when you go to them and you say, well, what's the steps for getting the humans to Mars? They'll say, oh, we got to build a better spacesuit. Huh? That's the last step in the process. We got a whole lot to learn before then.
Like getting folks to the ground. I mean, I think that's what always has struck me, that there hasn't been a stronger effort to integrate the two, because it seems like a no-brainer that Mars sample return can serve as your, uncrewed test concept, right? That you want to, as you said, how do you launch off the surface of Mars successfully? But also not just that, but are you actually using or validating technology that is directly relevant to human needs on the surface? I mean, I think probably the actual answer to that is that because there's no real technical limitations or constraints on what those human missions are even going to look like, that there's nothing that you can even use as a precursor now to really help you in a direct way. Would you agree with that?
Yeah.
And you can get conceptually, you can get data of what it's like to launch something through the Martian atmosphere.
Right.
But,
yeah. No,
but it's so ill-defined at this point that there's nothing you can even really put forward.
I've been an advocate of humans to Mars all my working career. worked on some studies. We tried some effort. We advocated it at the Planetary Society. It needs a big geopolitical initiative. The other thing that with the problem with Jared Isaacman's statement and with Elon Musk's push is there's no rationale for it. Mm-hmm. Elon is driven by his ideology of wanting to set up a utopian community on another world, an Ayn Rand kind of idealistic
the ultimate
view
John Galt, right?
Of this nirvana or a utopia on another world, and he's driven by that. Well, it's a firm driver for him, but it's not a society driver. It's not going to get the public support, and Elon, even with his wealth, isn't going to conduct it privately. So we have this dichotomy of the rationale for humans to Mars, which is about exploration and is about wondering if the human species will be confined to Earth or whether we will make it elsewhere. But it has to be logic to it. And these steps we're taking from a technology point of view are great. Robotics, artificial intelligence, virtual reality, all the things we can do, but we're not employing it in the big question of either sending humans to Mars or conducting the studies necessary to do it.
Do you feel that Musk's plan is viable from your perspective and history within aerospace engineering? Is that also might be part of it, right? That they just say, well, he's going to do it. He's going to put his money to it. We'll let him figure it out and we'll ride along and we'll get something out of that.
That's a convenient excuse. It's not real. There are two classes of people who say that. One who know it's not real, but they don't want to do it anyway. So they'll say, oh, good, Elon's going to do it. We'll just wait. And then the other class is the enthusiasts who really believe that is the way it's going to be done. And I think there's no evidence of that. Nothing much has changed in the whole history of the space age about our outlook about how to do humans to Mars. It's still big rockets, big spacesuits, big landing vehicles, and trying to cope with an environment which is totally hostile. We can't breathe. It's poisonous and has toxic chemicals on the surface and would irradiate us if we let anything go on.
It's only gotten worse over the years. The more we've understood Mars, harsher.
It's either made up of the unrealistic or the people who don't want to do it anyway and use it as an excuse. So no, I don't think it's realistic. And what's going on in the human program, unfortunately, Elon is so good at what he does. He has said he'd build the Mars architecture and use it on the moon. And that became the Artemis program. And now it's holding us back from the moon as well as holding us back from Mars.
Yeah. I mean, if nothing else, it turns a national objective into dependency on an individual to solve it, right? Like it hands the keys of a national goal over to a person and says, good luck, and I hope it works. And it makes the nation itself almost like a passive observer to it.
Yeah, and we're not and not accomplishing much. Now, I don't know. As I say, I used to be a great supporter of the whole humans to Mars goal. I thought it was a driver both for nations to get together. It was a driver to pull our technology, to pull our human capabilities along. And all of that may be true, but things are changing. Technology's changing. We don't use humans to do a lot of things that we used to use them for here on Earth anymore. Deep sea mining, underwater exploration, working on nuclear power plants. More and more of that is robotic and telerobotic, and getting more so as artificial intelligence goes along with the telerobotics. So I don't know now whether humans ever need to land on a planet again. I think they still need to operate and explore planets, but I don't know that they ever need to land on it. It's a pretty hostile place.
It lacks a certain romance, but I think that's more of our problem than the reality of the situation, perhaps.
But why
don't we feel that?
Why don't we feel that about exoplanets. We're never going to land there, but people get excited about what an exoplanet might be made out of because they want to explore it. And I think again, if NASA truly could be redefined as an exploration agency instead of as what they're doing, we would have a chance at this.
We'll be right back with the rest of our space policy edition of Planetary Radio after this short break.
Hi, I'm Kate Howells, Public Education Specialist for the Planetary Society. It's time to celebrate the most inspiring space moments and missions of 2025. Every year, we invite space fans around the world to help decide the Planetary Society's Best of the Year awards, honoring the discoveries, missions, and images that made us all look up in wonder. Now it's time to pick your favorites from 2025. From daring new spacecraft to breathtaking cosmic images, your votes help celebrate the people and projects pushing the boundaries of exploration. Cast your vote today at planetary.org/best of 2025. That's planetary.org/best of 2025.
So let's go back to Allan Hills, because I think this is an interesting comparison and contrast to this point that we find ourselves in, where, as we briefly mentioned, but let's just kind of recap what happened there, which was you had a Martian meteorite found in Antarctica, sat on a shelf for a few years, right? Was analyzed, and there were these very suggestive findings of chemistry and morphological shapes of bacteria-looking things. And you had a team publish a paper saying that, in their view, this was evidence of ancient life that was still subject to validation, but it was a peer-reviewed paper. It made is an understatement to say it made a splash. I mean, you were there, right? It was a major event.
President of the United States held a news conference on the White House lawn.
Right.
I mean, when in your work time, Casey,
right,
has the President of the United States said, "Hey, I got this from NASA. I want to call a press conference."
Right. And I think at the moment too, I was reminded in the context of it, Archaea had just been functionally discovered, right, as a new branch of life. You had the growing understanding of Europa as an ocean world. So I think there's like a broad increasing of awareness of the likelihood of the variety of ways that life can exist, and also potential habitats that particularly microbial life could exist. And it turns out, as you alluded to earlier, pretty much all those claims were ultimately shot down in that paper, right? Because just to be clear, I'd say the scientific consensus is clearly that was not life. I think there may be a few, and maybe even Chris McKay himself may dispute a few of that, but ultimately that was not a discovery of life on Mars. And it has struck me over the years that Allan Hills is repeatedly referred to as, by a lot of members of the scientific community, as this embarrassment almost, or a black eye, something that is to be avoided at all costs of recreating that. And I'm struck by both that attitude and the consequences that it led to. So how would you characterize that claim, how it was handled, and then also the consequences of it?
Well, I do think it was overhyped in the sense that...
But who was doing the overhype? I mean, who was doing the overhyping?
But, well, that's always a push and pull. The political seized on it. NASA fed it. But I also remember that the news conference very clearly, when the discovery was going to be announced, it was done very carefully. Mm-hmm. It wasn't announced by NASA. It was done by Science Magazine, I think. I could be wrong. It's a memory. But I think it was done by Science Magazine announcing that the paper was going to be published, and it said this. So it was basically an announcement of what this peer-reviewed paper in, I think it was Science, it could have been Nature, but I think it was Science, that was going to say. And NASA then came in and said, well, this is great news. It's very important. What do you do? So the choice I would give all these scientists who want to poo-poo it and say, oh, it might not be, would say, okay, we'll keep it secret from the public. We had this very interesting discovery, but we're going to keep it a secret. We don't tell the public what we've just spent all this money of their taxpayer money and this interesting discovery and the process that's going to go on from here. We shouldn't ballyhoo it because we don't want to confuse people. That's arrogant and stupid. It was a responsibility to tell the public and to seize on it. Now, the president got carried away, maybe another NASA administrator, not as clever as Dan Golden, would have said, wait a minute, Mr. President, don't get too far out on this. Hold back. I think maybe he did say that. And then some politician said, no, this is great for you. Get out there. I don't know.
But there were conditionals in it. Like, it's not that he's saying it is,
and the point is, I remember this very clearly. Even Clinton said it at the press conference, I'm sure. And now what do we have to do? We have to go up and we have to learn more.
Yeah.
And we have to someday bring back a sample. So that's what it drove. So all these scientists now who are embarrassed about it,
they have their careers to thank for it.
Their whole career, they owe to that discovery. Because we wouldn't have had 20 years of missions going to Mars with this kind of public interest.
I mean, tell me about that era of Mars exploration, though.
And the other thing I've got to say is when the news comes out months later that, so-and-so published a paper in Science saying that wasn't such a great discovery after all because it can be explained, and those really bits of microfossils are not really fossils, but could be this and that. And all of that came out. Was there a big scandal? Did somebody call for an investigation? Did somebody say the scientists are charlatans and they should be fired? No. They said, this is a scientific process. We put out a theory, we carefully examine it, we look at it, we show it openly to the world, we let other scientists look at it, we let everybody look at it, and then we say, what do we have to do from here? Science works. That's what the lesson of Allan Hills was. Science works. You discover something, it doesn't work out, but then you decide what the next experiment should be.
Yeah. Yeah, I mean, I think that's what it's hard for me to understand and where this, I think, internal community almost trauma comes from. But I mean, just real quick deviation here. Tell me the mid-90s, by the time you got to 96 when this discovery was announced, I mean, Mars exploration was pretty moribund by that point, right? Tell me what that was like during that era. I mean, you're running the Planetary Society, started the organization during probably the worst single decade for planetary science in its history so far. That includes this potential next 5 years, right?
Well, I hope the 80s turns out to be worse than these next 5.
Yeah, I mean, I'm saying, like, given even now, like, it was still worse, right? I mean, there was almost nothing going on new. That was the whole upwards push, right?
So it was a very political time. And of course, that's why the Planetary Society was formed. So the notion of Mars exploration had gotten a black eye, if you will, or an embarrassment, as I said, from the post-Viking, the fact that Viking didn't discover life. But as is going on now with the rest of the world, in particular China going to Mars, at that time Russia was building Mars rovers, and the Soviet Union, I should say, and had an active program of Mars exploration. And so we at the Planetary Society became advocates of doing things, international cooperation with the Russians and Soviets, not because we love Soviets or we were communists or some other political, ideological idea, but because we wanted to keep Mars exploration at the forefront of public knowledge. That's where the action was. So we wanted to bring that to the United States. And secondly, we wanted to use that as a lever to say, is the United States sit around while other countries explore Mars, or do we reactivate our program? Well, very fortunately, we had an administrator at NASA at that time in the 90s, by 1991, who was a great advocate of Mars exploration. And when Mars Observer, the one program that was started in the 1980s for Mars, failed in orbit around Mars, his reaction could have been, well, that didn't work out. I knew it's just too hard. We don't have the money to keep wasting on that. We'll give up. But he said the opposite. He came to the Planetary Society and he said, let's get more aggressive. We want to do Mars missions every opportunity. And of course, the Planetary Society, being Carl Sagan and Bruce Murray, I'm the third wheel, immediately said, yeah, we should do it every opportunity. In fact, we should do 2 every opportunity. So we came back with an aggressive recommendation. NASA came in and was terrific. Dan Golden did, and Wes Huntress, I should say, too. He was the head of the science program at that time. These were Mars people. They knew what they wanted to do at Mars, and they got the program going again with a commitment. Even in the face of mission failures, they committed to the additional Mars missions. And by the way, it wasn't a budget question. Dan Golden was criticized by the science community because he was willing to take a budget cut in the mid-1990s. He told Clinton that he'd accept the budget cut because we're going to do it cheaper, faster, better. I think he oversold that, but the result of that overselling was more Mars missions, which was more science, which has done us very good, instead of the cautious attitudes that are being sort of the intellectually pure attitudes that are being taken now, which is, we don't want to say anything that's not exactly correct.
So I want to emphasize 2 things from what you were just outlining there. One was that during the 1990s, I mean, there's a lot of interesting, I'd say, similarities. I don't want to overstate that, but some similarities at that era, right? So NASA's budget was trending, every budget was trending down. This is the era of big government is over, right? Kind of Clinton, small government initiatives. They had incentivized over 20% of NASA's workforce to leave over the course of 5 years through attrition and incentivized retirement. They were shrinking the workforce. They were shrinking its budget. And yeah, they're trying to pivot. Can we do smaller missions faster? And so like Pathfinder had already actually been approved and was underway when this Allan Hills meteorite discovery paper was published and all this kind of media attention happened. But there is, and so from what I could tell from the research that I did on this, the projections for NASA's budget for 97, 98, 99 were about $1 billion less than the projections for NASA's budget after Allan Hills meteorite for the same future years. And it does seem that there was a big, Al Gore, vice president, got really involved in this. There was a summit at the White House, workshop about origins, and this idea, this NASA Science Origins program kind of was born out of this discovery. But critically, not just for Mars, it was origins of the universe, it was the origins of life and origins of life on Earth. And it unlocked, it seemed to, about this $1 billion or so of extra money for NASA science after that. And so there's, as you said, it's really kicked up this exploration of Mars. But it really wasn't until 2000s that you had the Follow the Water. Scott Hubbard, our friend who ran the Mars program and really created this golden era of Mars exploration after that. And I think you really can tie a lot of that back to Allan Hills, even if it wasn't the claim. And again, they made a claim, it was disproven. But I think what you're saying here is that it unlocked, because they made it so strongly and clearly, it unlocked this deeper fascination and realization. Oh yeah, this is actually what's at stake. By exploring Mars this way, we could actually find something truly profound. And that is important to focus our attention and resources on. And so I don't understand, in a sense, this sense that the Allan Hills was this embarrassment after the fact for those same reasons.
And they tied it, you pointed out correctly, to life, that whole life issue, which then led NASA to create astrobiology as a discipline, and Astrobiology Institute, and the whole more general interest that ultimately led, thank goodness, to the Europa mission after a long time.
I would argue even probably James Webb itself. was born out of that, and then the increasing budget. That's an Origins mission.
So we had the discovery of the Allan Hills. We also had the discovery of exoplanets going on in those same years, the first discoveries of exoplanets. And then the whole connection between the possible other astrobiological targets. Now, we've been pretty simpatico on this discussion, Casey.
Yeah.
Are you ready for me to criticize you?
Go for it, Lou.
Okay. I don't. I think you're doing a fantastic job. But here's something that I think Dan Golden had right, and the current advocates of planetary science don't have right. Dan Golden said, I don't care about the budget. I can make it smaller, it doesn't matter. We're going to go to Mars, we're going to do this, and we're going to do it, and we're going to start a whole new astrobiology. We're going to learn this, and we're going to learn that. The budget followed the purpose. Right now, the focus of all discussions is about budget and not about purpose. The focus on the human space program is about budget and not about purpose. The focus on the science program is about how I've read a lot of your material and other material about, the Planetary Society budget used to be this and now it's that, and it's shrinking this, and there's so many less scientists working. All those things are true, but that's what follows the purpose, not what drives it. And so I think we should go back to that lesson that I think Dan had right, which is, make the budget smaller, but make sure you keep the Mars sample return mission. Mm-hmm. That's what should be the focus. Or keep the focus on what we're doing and why we're doing it, and not on, we want a bigger share of the pie. Yeah.
So let me answer that by a slight...
Don't get defensive. I think you're doing a great job.
I think that's a really important message, though, which is... it's illustrated by one I want to go into here. So I think it's worth discussing a little more, because I think ultimately there's a coalitional aspect of this that makes it hard to do that, harder than I want it to be, to be able to say this is should be our core motivation, right? I mean, first I think is that the decadal survey exists now and it didn't exist in 96. And so you have this National Academies stamped, approved, this are the goals, and life is in there. But there's everything else is in there too, right? That it's a coalition document, not a clear statement of purpose. So that's distinct. And I think that makes it, again, from a coalition building perspective, difficult to assemble something that is acceptable to everybody if you take a strong position on that, like kind of one out of the 10 things that are important. The other aspect, though, is that I do think life is, I was a member of the Planetary Society for a long time before I started working there. And like you, I feel that the life question is what resonates with me most deeply, that is the fundamental, profound motivator. But seeing how a lot of the community talk about life, and they created this astrobiology institute within NASA, but it never got really above $50-ish million. And you have a few kind of scattered astrobiology program missions, but there's no astrobiology program line, right? They're all split up between different scientific disciplines, and some are more astrobiology adjacent than others. That it clearly isn't, there's something about the structure and interpretation of the life question in the scientific community that is a real challenge here. And I'll use this segue into saying, one of the things I sent you as part of this discussion that spurred this whole topic was this new paper that did come out back in September that announced a potential biosignature detection by the Perseverance rover that is now in its sample cache, ready to come home. The kind of the core, what they were looking for, I would argue, right, of why we sent Perseverance to Mars, why sample return should happen. But what Nature now publishes is also the reviewer comments, which is fascinating. So you can see when the paper was submitted for peer review, you can see the comments from their peer reviewers and the back and forth that they had. And there is an anonymous reviewer that provided what I thought was a very revealing and, to me, frustrating perspective that basically said, I like the data. I hate how you're framing this as a potential biosignature. And they literally say, I'm trying to find the exact quote here, is that, this manuscript will not escape the fate of McKay's paper, the Allan Hills meteorite, and will be dismissed by the community as too controversial. This is a situation that can damage, and they're saying literally here, I'm reading pretty much verbatim here, damageable to the reputation of the field of astrobiology. And so the result was you have a paper that came out that basically says that it found a potential, and it emphasizes potential, and it's listed testable hypotheses of how you would validate it. But they actually couldn't say the word biosignature in it. They took it out at the reviewer's demand. And then it even gets worse after that. But this idea that Allan Hills was seen as such a pariah, you don't even want to be seen in the same world with that.
I'm just thinking, it's going to have the same fate as the McKay paper, lead to 20 years of exploration and science and new discoveries. No, it won't have it, because it's so frustrating, because it's so bureaucratic. Everything is wanting to be put into a little niche, and that niche is what this one, from this guy's perspective, that guy, they end up committeeing it to death. Committees always reach the lowest possible denominator of a decision, because they can't take the big leap. Mm-hmm. And we don't have anybody like Dan Golden was in the 90s, like Carl Sagan and Bruce Murray were in the 90s, 80s, and 90s, that can rise above the bureaucratic argument about, is this, Carl used to make statements that infuriated Bruce. Some of our board meetings were pretty exciting. Carl would infuriate Bruce or Bruce would say, "You said something about pyramids on Mars." Carl said, "What did I say?" And then they'd read, people are interested in pyramid structures, Bruce. I didn't say there were pyramids on Mars, but people want to know what they are because they look like pyramids. Yeah. And that drives exploration. And that wasn't wrong. And that's the same thing now. We don't have people now who are willing. We were very careful. Carl was the most careful of all. I mean, I remember with the Allan Hills meteorite, and unfortunately, he was pretty sick. This was the later years, just before he died. But I remember having discussions with him, and he says, "This may not stand up. We have to be cautious in what we say about it." Now, we do. We have to be cautious what we say about it. We don't want to go BSing and lying about it. We want to keep rigorous our science credentials in what we say. But it's rigorous to say this is an exciting discovery about the possibility of life on Mars, and it could be a biosignature. And what we have to do is get that back in the laboratory to see if it's a biosignature, instead of hemming and hawing about some intellectual thumb-sucking in a science magazine.
Well, I mean, I think to that point, I think what I've read both papers, and what struck me about the McKay, and this reviewer highlights the last line of the McKay paper of 96 that says, "We collectively conclude that this is evidence for primitive life on early Mars." Like that's it. That was their claim, and they made their claim clearly. And I think that's why it was exciting. And it was exciting. There wasn't, and I think to emphasize, you mentioned this, let's emphasize, this paper wasn't shown to be malicious or inaccurate. That was their best understanding. That was their conclusion. You could argue that they were too exuberant about it, but it wasn't there. It was a claim. And then, as you said, the process of science.
And it was peer reviewed.
And it went through peer review.
If I can jump to this, it wasn't published in archive,
Right. This is in
archive, which is, people put out all kinds of speculation in archive, and it may or may you don't call a press conference usually on the basis. Sometimes they do on the basis of what you see in archive. This was peer reviewed, and it was solid work by I know two of those authors, they were very conservative people.
Yeah.
It
was peer reviewed in one of the most prestigious journals. Yeah.
Now you point out it was published this thing in September, but it was a year ago or 9 months, 10 months ago that they first made that discovery and pointed out this thing. So what's happened in the 9 months since then is not that it's been debunked, it's got stronger.
Yeah.
And now this reviewer is criticizing the fact that it got stronger because he's scared. Well,
that's what's so interesting. That's what I'm so fascinated by.
Well,
right?
It's bureaucratic. I mean, scientists are as bad as industry. They all want their special interests protected. I have no love for science committees. In fact, I hate science committees.
I've never heard anyone say they love a science committee, I have to say, any committee.
But they're a special interest group. Scientists are a special interest group. They're interested in their science and their research grants and their funding. They're not only a few of them rise above the I got to take care of this level to take the broader view of exploration, which is, I may not be the person working on this, but this is the kind of thing that NASA should be doing.
Mm-hmm. This is where I want to just tie these two threads together of Mars sample return and Allan Hills, though, because this is where what goal does this serve? Ultimately. And just to be clear, the other reviewers were generally fine. There's a level of reactivity into this, and I'll post this, and it's public. This is public, but I'll post this onto the show notes. Reading through is, to me, an extraordinary review that it goes so far beyond. They're not checking for scientific review. They're tone checking. And they're saying, no, you are going to damage the reputation of this field. They ultimately recommend rejection, even after extensive reviews, after removing biosignatures, because they claim that they still clearly imply beneath the surface that they think it's a biosignature. Like even the idea to think that deserves to be rejected, which is, again, to me, not what a reviewer is there to do. They're saying, is the science solid, which it was.
This is the same guy, this reviewer.
Yeah.
He was working for the Catholic Church in 1500s when Galileo submitted his paper.
The heresy. Well, but I think
Copernicus submitted his heliocentric notion. He says, this is going to ruin the whole structure of our study. I get it.
Yeah, well, I'm not necessarily trying to pick on this one reviewer, but I think it's indicative. This is what I mean of when you go to bring it back to your critique about Search for Life as being this kind of centralizing message and organizing aspect, is that there clearly is some really deep fissures in the scientific community that do not accept that as a valid organizing. I'm not saying that I can't read the soul of this individual person, but just as not a valid organizational principle, and maybe not even as much of a valid scientific endeavor, right? Based on some of the reactions you've seen. And so building a broader coalition to support NASA science on the predicate of this should be the primary goal should be finding life beyond Earth, which is what I would love to see.
I spent a lot of my professional career answering questions from the public.
Yeah.
Why do we spend billions of dollars in space?
Right.
And I asked them, why do you think we should spend billions of dollars a question? It always comes down to life. Mm-hmm. This is what we're doing. What else are we doing?
Yeah.
If we're not going to be looking overtly, dealing with life and the possibility of life, we wouldn't have a space program. If we took science, all the NASA science, and stuck it in the National Science Foundation, this is a point that Bruce Murray used to make. Take all of the good science that NASA does and give it to the science community to evaluate, the National Science Foundation. It will get it'll get a tenth of the budget it gets because it doesn't compare to physics. It doesn't compare to biology. It doesn't compare to health science. It doesn't compare to environmental science. Those are the things that will attract the scientists. We do more than that. We're exploring the very fundamental questions of human existence.
Yeah.
And that's what justifies this $25 billion NASA budget and the effort we got to make on it. And as soon as we start looking away from that, then we get into the dysfunction that is now running NASA and running the science program.
We had very similar, at least superficially, conditions, right? Where you had budgets going down, we don't have a permanent NASA administrator, but change-minded administration. And then you had a potential discovery. But I would claim, and this is kind of what I feel out as a consequence of this, by diluting the message from this paper, by making them take out the words biosignature, and it's clarity, right? The McKay paper from 96, they went out and this is what we conclude. Super clear, right? And I think that's the fair thing to do versus forcing people to kind of dance around what they're actually saying, which is this is a potential biosignature. But then because of that, it dilutes the message, it dilutes the excitement, and it dilutes the ability of the system, the political system, to properly respond to something that could be really consequential and important because of some perceived reputational damage that I don't understand how one measures that to begin with. I mean, the other thing I like to point out to folks, half the current Congress believes that there are literally aliens flying around in UAPs right now, right?
Exactly.
I mean, it's no longer some fringe thing. We have our Secretary of State believing that. You have our Vice President saying that those are aliens or maybe demons, right? You have the level of, this isn't not, you don't have William Proxmire running around giving a golden fleece anymore, right, to SETI. But it seems we have really internalized that is still the conditions in which the community is operating in.
It's a mystery. That's a mystery, and I agree with you. Mystery to me is how this Cheyava Falls discovery was made and announced about the same time as this administration said they're going to cancel Mars sample return and leave that sample up there.
Yeah.
There you have, we discovered a possible extraterrestrial life, but we're not interested. We're not going to go get it. And practically the same month of news. I can't understand why the advocates in NASA and for NASA didn't make that a bigger push.
Well, I think it's that reaction to downplay the potential of it because of again, pointing to Allan Hills, this internalized idea that Allan Hills was an embarrassment, that you've had then a couple other high profile things like the phosphenes claim at Venus, which probably wasn't correct. Just before that, you had the retraction of the arsenic life paper, which was another kind of big, not anything like this, but I think from 2010s with a great article in the New York Times talking about how, it was, again, a claim going forward. They retracted the paper. There was nothing wrong with the actual paper. The claim just wasn't validated. So it's not clear why they had to go that extra step of retracting it. So there must be some internal reaction or immune system defense or something that's being seen as like, we must preserve some sort of high-minded.
Glad to hear you say that, Casey, because I think the Planetary Society should be out front, not accepting the scientific community's point of view, almost, if necessary, rejecting it. We have a good history of that. In the early 1990s, the scientific community, including committees, put down the idea of rovers on Mars. You know what a rover weighs 10 kilograms? You know how many instruments I can build for 10 kilograms and what I can use that money for? That's just a waste. It's a stunt. Don't put rovers on Mars. That was actually a science community view in the late 80s, early 90s here in the U.S.
Well, kind of like with cameras.
Cameras even, back in the 60s. So it's the Planetary Society's job to not take the science community's view, to take the public view. That's who these missions are done for.
How do you, I resonate with what you're saying, but also there's a caution there, right? Like, how do you responsibly know when to reject, in a sense, scientific consensus? Because that's certainly happening a lot these days, right? And mostly, I would say, not for good things.
Because you don't reject the science.
Yeah.
You reject the opinion. You're not, I don't call on the Planetary Society to publish papers disagreeing with scientists who have peer-reviewed papers and say the science is all bunk or something like that. I'm dealing with of building on it, of taking that peer-reviewed paper, taking that process, taking the astrobiology results, and making it a clarion call for the investigation of the origin of life and discoveries of extraterrestrial life.
Lou, I've taken up a lot of your time, and I want to thank you for your time and opinions on this.
I have opinions, of course. One opinion I have to admit, I could be wrong.
Always a good way to finish something, right? That's fair.
But it's the synthesis of opinions that really counts.
Yeah.
And synthesis of opinions of good people. I did live in an extraordinary age with Sagan and Murray because they led the synthesis of really great people in putting these together. We do need more of that. That's missing in our society, and I have no better answer to that. Our society, broadly, lowercase s, then I have no better answer on that than you do. So we'll just have to keep trying.
Sounds like a good plan. Lou Friedman, Executive Director Emeritus of the Planetary Society. Thank you again for being here. It's always fun to talk to you.
Okay, thanks, Casey.
We've reached the end of this month's episode of the Space Policy Edition of Planetary Radio. But we will be back next month with more discussions on the politics and philosophies and ideas that power space science and exploration. Help others, in the meantime, learn more about space policy and the Planetary Society by leaving a review and rating this show on platforms like Apple Podcasts or Spotify or wherever you listen to this show. Your input and interactions really help us be discovered by other curious minds, and that will help them find their place in space through Planetary Radio. You can also send us, including me, your thoughts and questions at planetaryradio@planetary.org. Or if you're a Planetary Society member, and I hope you are, leave me a comment in the Planetary Radio space in our online member community. Mark Hilverda and Ray Paoletta are our associate producers of the show. Andrew Lucas is our audio editor. Me, Casey Dreyer, and Merk Boyan, my colleague, composed and performed our Space Policy Edition theme. The Space Policy Edition is a production of the Planetary Society, an independent, nonprofit space outreach organization based in Pasadena, California. We are membership-based, and anybody, even you, can become a member. They start at just $4 a month. That's nothing these days. Find out more at planetary.org/join. Until next month, ad astra.